the truly periodic table. The periodic table is this chart with a strange shape, with letters and numbers, neither a square nor a rectangle, with such a characteristic shape. Unmistakable. Some people know what each of these letters represent. C is the chemical symbol for carbon. O is the chemical symbol for oxygen. The chemical symbol for iron is Fe. Zn is zinc. There are even those who know the chemical symbol for sodium is Na, because it comes from the Latin natrium. Or that the chemical symbol for gold is Au, because in Latin it was called aurus. And also some know the meaning of the numbers that appear next to the letters, like for example the atomic number, which is the number of positive and negative charges of the atom. But what exactly is the periodic table? The periodic table is a chart that represents all 118 chemical elements that constitute the known universe. Everything around us is made up of at least one of these elements. 94 of these elements can be found in nature, and the rest were obtained in laboratories. 118 elements may seem too little for an entire universe, but it's not. Let's see. In stars like the Sun, 94% of all the atoms are hydrogen. The human body itself is very scarce on chemical elements. For every 100 kilos of weight, 65 kilos are oxygen atoms, 18 kilos are carbon atoms, and 10 kilos are hydrogen atoms, which leaves little room for all the other essential elements. Nitrogen, calcium, phosphorus, potassium, sulfur, chlorine, sodium, magnesium, iron, cobalt, copper, zinc, iodine, selenium, fluorine. The wonder of the chemical elements is that they combine with each other, and there's an almost infinite number of possible combinations that produce all the different chemical compounds needed to keep us alive and build everything around us. The water we drink, obtained by combining an oxygen atom and 2 hydrogen atoms. The glass we drink it from. The sugar in our coffee. The coffee. The cup and the metal of the little spoon we stir it with. The plastic our computer is made of. The rubber on the tires of our car and the gasoline that makes it run. Proteins. DNA. Everything around us and inside us are atoms that combined. An atom is the smallest recognized division of a chemical element and consists of a central core, with protons, positive charge, and neutrons, no charge. Surrounded by a cloud of electrons, negative charge. The properties of each chemical element are defined by the atom's nucleus and by the way electrons distribute in layers around it. These properties define the way atoms combine, or not really. Atoms react with each other through electrons of the last layer, the outermost layer. If the last layer has the same number of electrons, this means that the properties of these atoms are identical. The distribution of the elements in the lines and columns of the periodic table is not random, or just a question of design. The position of an element on the table tells us something about its chemical and material properties, and helps us to know and predict how 2 elements can combine. The periodic table organizes the elements from smallest to largest, according to its core and the distribution of electrons. In the first column of the table, we have the elements that have a single electron in the outer layer. And in the last column, we have those who have filled this layer. That's why each chemical element in the periodic table has a very well-defined neighborhood. Above and below it has elements with the same distribution of electrons and very similar properties. And on its right, it has an element that has an electron and one proton more, and therefore has different properties. We call it periodic because in this table the elements become similar again periodically. Let's see, if we start at 3, lithium, the properties will vary regularly along the line until 10, neon. Here, the last layer of electrons gets full, and we move on to the next line and back to the first column. The properties of this element, 11, sodium, are again identical to the element that is directly above it, and so on. The tricky part is that the number of electrons filling one layer varies, and their distribution follows well-defined rules of quantum chemistry. 2 in the first, 8 in the second, 18 in the third, but in 2 phases. Which makes it necessary to distribute the chemical elements in the table in such a weird way. But in the end, everything makes sense, and we have the whole universe in a single table.